Chapter 5 is all about writing linear equations, and 5.1 is writing linear equations in slope-intercept form. So this should really be a review from last chapter. What we're just focusing today is writing them ourselves, right? So a quick overview of the lesson. We're going to just kind of review slope-intercept form. Y equals mx plus b. M is slope, b is y-intercept. The x and y are the pairs of points that you get when you plug in an x value. And then we're going to write an equation in slope-intercept form given different information. Just keep in mind, no matter what they give us, we need to find the slope, we need to find the y-intercept, and then we're done. So modeling real-world situations using linear equations. And then finally, I just want to go over quickly how you can always check your work on Desmos. It's a really good tool for you to see if you're doing it right, while you're going along. So first, review of slope-intercept form. So y equals mx plus b. That's the generic form. Always needs to look like that. So just keep in mind, you only got to find two things: the slope and the y-intercept. And the y-intercept is just where does your line cross the y-axis? And we can see it's right there at 4 or 0, 4. And so we already got that. We already got the y-intercept. And we can also see it in the equation right there. Plus 4 plus b, right, is a 4. That's it, okay? Now all we need to do is the slope, so we'll just find any 2 points on the line. I could pick this one and this one, or this one, or this one, anyone, or this one, and I'll do that one. So I'm gonna ask myself, how do I get from here to here? Well, I have to go up 1, so that's a rise of 1. I have to go over 2, so it's a run of 2. And slope is just my rise, which is 1, over my run, which is 2. And notice, that is exactly what I see right here. So that's all I need to do to find slope-intercept form, find my rise, find my run, to get your slope, get your y-intercept, and you are done. All right? So now back to writing equations. Write an equation for the line with the slope of -2 and a y-intercept of 5. Well, all I need to do is plug in the slope, right? That's m. So I'm just going to rewrite that. So I'm going to have y equals -2x. And then a y-intercept of 5. So I'm just going to plug that in for b, plus 5, and I'm done. That's all I have to do if they give us everything I need. Next, sometimes they'll give you a graph, like in this case, and they're just asking you which one of these equations is that graph. Still, the same rule applies. I need to find two things, and those two things are slope and y-intercept. And in this case, notice the point that they gave me is the y-intercept. That's where it crosses the y-axis. So that's really easy. I already know that b is 3. So now all I have to do in this one is find the slope. So I'm going to pick any other point on the line. I'll pick this one right here. And all I have to do is ask myself, to get from here to there, what do I have to do? So I could think of this as, I could go down 2 if I wanted, which would be -2. And I'm going to go over to the right 5 spaces, which is positive 5. And so my slope is -2. It's my rise over my run, which is 5. And notice, the way we checked slope, it should be negative if it's going up to the left. And it's going up towards the left, and it's negative, so we did that right. If it's going up to the right, it should be positive, and that's a nice check for you to make sure you didn't do it like a sign error. Anyway, all I have to do is then plug my slope right in for m, and I get y equals -2/5 x. Keep that in mind. The slope is just the m. It has nothing to do with the x. Slope is just that -2/5. And you are done. So far, we focused on finding the slope by looking at the graph, and that's totally fine. But you also can just look at the points and figure it out that way. Okay, so just remember, slope is rise over run, and rise is just how much am I changing my y-axis, right? I'm going to go up from here to here. I'm going up 3. But we can also see that 3 by looking at the difference in our y values, right? I ended up at 2, and I started at -1. And to get from one to the other, I had to go up 3 spaces. And we can see that here, because if I say slope is rise over run, we already know the rise is 3, right? But the rise is just how much your y value is changing, and we can see that if we take the difference in the y values. So again, the first y value I had was -1, and I ended up at a y value of 2. So if I take that difference, 2 minus -1, remember minusing a negative is the same as adding a positive, I end up with 3, which is exactly what we had by just looking at the graph, okay? So we can find the change in our y value or the rise by just looking at what happens in the y values. Now if I look at I'm just going to change the color real quick. Now I've just got to look at the x values to see what my run is. Again, so my run is how much we're changing along the x-axis. Well, I'm going from here, 1, 2, 3, 4, going over 4 spaces. So we know our run is 4. But again, we can see that by just looking at the values, right? I started at an x of 0 and I got to an x of 4. And we can see the run and just how much is that x value changing. And we can calculate that by just taking the difference of the x value. So again, the one thing here is if this was my first point and that was y1, this has to be x1. I can't mix that up. That can't be x2. And then this would have to be x2, right? So I ended up at 4. I started at 0, and that difference is 4. So we can see it either way on the graph or by doing the equation. You're going to get the same answer. So it's just a way of calculating slope. And then finally, just the equation in this line then is going to be y equals, well, we know the slope, m, x, plus b. And I can see b right here is -1, right? The y-intercept is going to be -1, okay? So we have 3/4 x minus 1. The points are 0, -1, 4, 2 that we're connecting, right? So there's a good chance to just jump over to Desmos real quick and see how we can look at this equation either way. So let's just see we just had the points, 0, -1, and 4, 2, right? So we could just pop over to Desmos. Is to just kind of jump back to that slope equation and review that really quickly. So far we focused on finding the slope by looking at the graph, and that's totally fine. But you also can just look at the points and figure it out that way. Okay, so just remember slope is rise over run, and rise is just how much am I changing on my y-axis, right? I'm going to go up from here to here. I'm going up 3. But we can also see that 3 by looking at the difference in our y values, right? I ended up at 2 and I started at -1. And to get from one to the other, I had to go up 3 spaces. And we can see that here, because if I say slope is rise over run, we already know it's the rise is 3, right? But the rise is just how much your y value is changing. And we can see that if we take the difference in the y values. So again, the first y value I had was -1. And I ended up at a y value of 2. So if I take that difference, 2 minus -1, remember minusing a negative is the same as adding a positive, I end up with 3, which is exactly what we had by just looking at the graph, okay? So we can find the change in our y value or the rise by just looking at what happens in the y values. Now if I look at, I'm just going to change the color real quick. Now I've just got to look at the x values to see what my run is. Again, so my run is how much we're changing along the x-axis. Well, I'm going from here, 1, 2, 3, 4, going over 4 spaces. So we know our run is 4. But again, we can see that by just looking at the values, right? I started at an x of 0 and I got to an x of 4. And we can see the run and just how much is that x value changing. We can calculate that by just taking the difference of the x value. So again, the one thing here is if this was my first point and that was y1, this has to be x1. I can't mix that up. That can't be x2. And then this would have to be x2, right? So I ended up at 4. I started at 0, and that difference is 4. So we can see it either way on the graph or by doing the equation. You're going to get the same answer. So it's just a way of calculating slope. And then finally, just the equation in this line then is going to be y equals, well, we know the slope, m, x, plus b. And I can see b right here is -1, right? The y-intercept is going to be -1, okay? So we have 3/4 x minus 1. A couple more things to go over. So writing linear functions in slope-intercept form. That's something that can confuse a lot of students, but it's actually really simple. And the thing to remember is just y is just synonymous or means the same thing as f of x. That's it. So if I think of this as my y-axis, my y value, I can also think of that as giving me my f of x value. They're the same. X doesn't change. X-axis is still the same, right? So just remember, all this is saying is that when we plug in some x value, we're going to get out some y value. So now they say, write an equation for the linear function of f with the values f of 0 equals 5. And all that means is if we plug in x is 0, we get y equals 5. And remember that combo, that pair is a point, 0, 5. So we're still getting x and y values even though we're writing the equation a little bit differently. And then f of 4 equals 17. Same thing, we're plugging in an x value of 4. And we're getting a y value of 17, and that is a point for 17. And you can see we graphed those points. So we graphed them. Again, you could go in Desmos and graph them. Now all we got to do is find the slope and the y-intercept, and conveniently, that point, the y-intercept is already there, so we already know the y-intercept is 5. So that was easy. And now we just got to find the slope. So all I got to do is ask myself to get from here to here, what do I have to do? How far do I have to go up, my rise, and how far do I have to go over? Well, to go up, we're going from 5 up to 17. So that is 12. And to go over, we are going over from 0 to 4, and that takes 4 spaces. So my rise is 12, my run is 4, and I can reduce that to just 3. So to write my equation, right? Y equals slope 3, x plus y-intercept, which is 5, plus 5, and we are done. So last one, modeling a real-world situation in slope-intercept form, okay? We're going to go to the bottom first. The key here is this. Your y value, your f of x value, those are the same, right? Your x-axis is still going to be down here, and your x-axis is going to be your inputs. Like, what are we inputting? Another way to think about it is what is changing, right, through the problem. What is changing in the problem? Okay, but here's your tips. 1, we're always going to start at a y-intercept. So your y-intercept is like your initial point, your starting value, right? So you want to think, before we do anything, what's our starting point? That's your y-intercept, okay? 2, use your slope to find the next point, connect them, and you're done. So let's go up to the problem. A recording studio charges musicians an initial fee of $50 to record an album. So again, initial, starting point. I know right away that's my y-intercept. So I'm going to put that right there. So that's at 0 hours. I haven't done any hours yet, right? That's 0 hours. I have to spend $50 just for the privilege of getting some studio time. That's my y-intercept. Already moving on to the next thing, right? Okay, now, studio time costs an additional $35 per hour. Notice this though, it's per hour. That can change depending on the number of hours. And remember, the x value is what's changing. This is going to be hours, because the number of hours can change. The fee, right, the initial fee cannot change. So this is going to be the number of hours. And so now it says $35 per hour. So we'll just find another point on the graph, and then we'll talk about how we actually already know our slope. Okay, so let's think about it. Let's say we take 1 hour. Well, I have to spend another $35. So I already spent 50, so I go 10, 20, 30, and 5. That's $85, right? So after 1 hour, I'm spending $85. Let's say we actually need another hour. It's 2 hours to record. So we're going to go over to 2. Okay, so we're at 2 hours, right? And I go up 35, up 5, 10, 20, 30. Right there, it's $120. So after 2 hours, we spend $120 total. Okay, so I can connect these, graph my line. All right, and notice we're going up, right? If we want to look at the rise and the run to find the slope, we're going up $35 for every 1 hour that we are going over, right? We spend an extra $35 for every 1 hour of recording time. So notice it has nothing to do with hills, right? Slope in this case is the rate of change. And what the rate of change is I am changing. I'm spending 35 more every hour that I want to record. Okay? So that's a slope. But notice we already knew the slope, right? So for those of you who picked up on that right away, you know right away the equation of this line was going to be y equals 35 per hour per x, so 35 per hour, which is our x value, and plus the 50, because no matter what, that 50 is set. I have to pay that 50 no matter what. It's not changing. So that's that static y-intercept. So you should have seen that right away. That's the y-intercept, and then 35 is going to be the slope. And if you weren't, you can graph it, and you can find the slope that way. Okay, last thing, find the total cost of recording an album that takes 10 hours. Well, we already know what the equation is, so we just got to ask ourselves, how much is it going to cost when x is 10, right? X is the number of hours. And I still have to pay that 50 no matter what. So I got to spend $350 for the hourly time, plus my initial fee of 50, and that means I am spending $400 if I want 10 hours to record an album. So that is that. So watch the lesson, go take your assignment, then hang out, go to the Hangouts later if you have any questions. All right, best of luck, guys, and I'm here to help you if you need it.